we're doing a force thing, and I will warn you for this. In order for this to be funny, do not let me take your phone. Okay? Don't do it. No, somebody needs to be on their phone for this to work. But anyway, excuse me. I'm going to talk about Newton's laws, then we're going to figure these out, then we're going to come back to Newton's laws, and then first though, I want to point out to everybody watching at home that they messed up in that video that you watched for the check-in activity. They said 9.81 instead of negative 9.81. That your weight, the force they were calculating, is going to be in the down direction, so it would be negative. And then if 9.81 is negative, then the force will end up negative and everything's in the down direction. There's a question on your practice where it's got to be negative, so be careful. There's also one that says left and right. You've got to put directions on there by saying left or right, and it's got to be left or right with a lowercase l or a lowercase r, otherwise it won't work because Google is stupid. That's on record. Now, I know you just watched the video, but who's got a good definition for Newton's first law? Without looking it up. Yeah, object in motion stays in motion, object in motion stays in motion. Yep. I got my own version of it here. It says object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction. Because it's not going to turn unless a force pushes on it somehow. With the same speed and in the same direction unless acted upon by an unbalanced force. You may have heard it before, just another force or an outside force. I like to say unbalanced force because if you got balanced forces on the thing, then you let me take it. Okay. As you can see, I'm pulling this way and she's pulling that way, so the phone is staying at rest.
I thought I was in trouble.
But
so
there were, but yeah, I like to do that. So I just tried to take a student's phone. We were cooperating with each other. It wasn't a dramatic situation. Well, it was constructively dramatic, but not. Anyway, they're pulling one way, I'm pulling the other way, but the phone wasn't moving. So there were forces on the phone, but it's they were balanced. So just because there's an outside force, there were two outside forces. It's not going to move unless they're unbalanced forces. And eventually I let go and then everything was fine. Yes?
You need to sanitize your hands.
Oh.
It's corona.
Oh, yes, here we go. Oh, here we go. There we go. Okay, we're good. So, let's start thinking about these boxes here. People in virtual land can probably see it, but can y'all see this 10 and this 4 right here?
No.
This box has a 10 going this way and a 4 going this way. Newtons is the unit for force. So if this is 10 newtons and this is 4 newtons, which way is this box going to move?
Back.
To the left.
This way, to the left. I guess that's left. What would be the net force? 6 is right. Yeah, I know I didn't tell y'all how to do net force, but that's it. If you got opposite forces, you subtract them, and the net force will be in the direction of the larger force, and it'll be the difference of the two forces. So 10 minus 4 is 6, and 10 is bigger, so it's 6 to the left. So our net force here is 6 newtons to the left. Newtons isn't as fun as saying meters, but I mean meters. But it's fine. What about number V? We've got 12 going to the left and 12 going to the right. What's the net force?
0.
0, that's right. And we don't need a direction because it's 0 on.
On.
Yeah, it says on. Can
But
I
it went through the 0.
can I make it not say? I don't like doing that. Okay, that looks
Now
a little
it's
bit
on spaced out.
on. This number C has 12 to the left, and then it's got 12 to the right, and then it's got 12 to the right again. What's the net force there?
12 right.
12 what?
Right.
12 to the right, yeah. All right. So this one's 12 to the right. Now these are questions that kind of trip people up. That part was kind of easy. But now, which out of one or more of these, which are accelerating?
A and C.
A and C could be accelerating. Yeah, that's right, because they have a force on them. When something has a force on it and it's unbalanced, it's going to speed up or change direction. And remember, even if something's going the same speed and it changes direction, because acceleration is a vector and it includes direction, scalars don't include direction. Because acceleration is a vector, it will have an acceleration. It's just, instead of going 7 meters per second to the north, now it's going 7 meters per second to the west, or whichever way it turned. Which have balanced forces out of those?
B.
B. B is the only one, yeah. I can see how some people might say C because it's got 12 this way and 12 this way, but there's an additional 12. So really they could have drawn this like 12 this way and 24 this way, which is not balanced. So yeah, it's just B. This one, when I have people doing this on their own, this one trips everybody up. So imagine which one of these could be already traveling to the right, and when the force we drew happens to it, it slows down.
Wait, what?
If one of these is, which one of these, if it were already moving to the right, so which way is right? If it's going this way, which force would slow it down? A, B, or C?
A and B.
A.
B wouldn't slow it down. But
It
we're
would slow it down.
in physics land, if there's 0 newtons, that means 0 newtons for air resistance or anything else.
It
So
would be
Says
moving.
moving to the right, then you have to apply the forces that were on the left, and it would slow to a stop. Same
well,
with
with B, you'd apply 0 newtons. Or, I mean, if you applied 12 this way and 12 that way, you still,
Right, but
it's going, still just going to keep going. So it's only A. Since the force would have to be in the opposite direction to slow it down. If I'm going this way, and then I get a force to the left, it'll slow me down. I don't know why I'm using my head. Maybe it's because it's up there by the camera. So C would, if it were traveling to the right, and then it gets a force to the right, it's going to speed it up. So that's why it's not C. Which could be traveling at constant speed. Are y'all listening out there? Is it Friday?
Yes.
yes.
Constant speed is just B. That's right. Any other one is going to be speeding up, slowing down, changing direction. I guess since they said speed, it could change direction and still have the right speed, but that's a technicality. Which cannot be accelerating.
B.
Just B. Yeah. Saying it's a constant speed and saying it cannot be accelerating is kind of the same thing, but I wanted to make sure everybody's thinking about that correctly. Which could change direction.
B.
C.
A lot of these are either B or A and C, and this one is A and C. Like with the example I had with this one, if it's going this way and then it slows down and stops, if you keep applying that force, it could start going the opposite way. Or if one of these were traveling into the page or out of the page, like this, if this one were going out of the page and then you apply the 12 to it, it'll change direction. It'll go.
What was that?
Yeah. And we're skipping this last one. All right, so I talked about Newton's first law, Newton's second law, and then we're going to do one of those little blanks. Newton's second law is, do I need to be on the camera for this? Probably not. Newton's second law is basically saying that if you have something with the low mass and something with the high mass, and you push each with the same force, the thing with the low mass is going to accelerate faster than the one with the high mass. You know, it's harder to move heavy things, right? So, and I say heavy, that's a weight word. I mean more massive. It only has a weight if there's gravity. If you're in space and you have a real light thing and a real heavy thing, and you push each with the same force, it'll still, the light thing will still go flying and the heavy thing will still be like, So yeah, first law is object in motion stays in motion, object at rest stays at rest. In motion with the same speed and in the same direction if it's in motion, unless acted upon by an unbalanced force. The second law is if there's a light thing, if there's a low mass thing and a high mass thing, and you do each with the same force, then the low mass thing will have greater acceleration. And the third law. Who's got the third law here?
When there's action, there's always a reaction.
That's the action-reaction law, that's right. So the third law is for every action there's an equal and opposite reaction. And a more official type version says, when one object exerts a force on a second object, the second object simultaneously exerts a force equal in magnitude and opposite in direction on the first object. It's just a fancy way of saying for every action there's an equal and opposite reaction. So, I'm going to do this example right here. You push your knuckles into a table and your knuckles start to hurt. I've been using that table, but the camera can't see me, so I'm going to use this as a table and I'll push this way. Ready? This is kind of softer than the... My knuckles are not hurting. What about this? I can't fit in there.
Are you purposely trying to lift
Yes, it says I have to do that.
Or you can pretend.
Or you can pretend you're hurting your knuckles.
Which Newton's law does that? Is it 1, 2, or 3? When I push my... Why is it 3?
Because the whiteboard's pushing back on your fist with the same force in the opposite direction.
Imagine a non-living thing actually.
Yes. And if I'm doing this with the table, I'll do it with the table here, and they can't see me, but I'm pressing down into the table. They talked a little bit about normal force in the video. Normal force is one of these Newton's third law of forces. So if I push down into the table, and if the table doesn't break, which the table's not going to break, the table is pushing back with exactly the same force that I'm pushing down with. And I know that because of Newton's first law. An object at rest, the table, will stay at rest unless acted upon by an unbalanced force. And I am not applying an unbalanced force right now. I'm applying a force, but the table is applying just the same force, which makes it balanced. And that's why the table is not breaking. That's how strong the table is. So, normal force is that reaction force, where I'm pushing down and the table is supporting my hand. See, now my hand hurts. Yeah. Like I said, on these ones that have direction on them, be careful. You say left or right or negative or down. And I think y'all are going to be fine. Try out that force intro that's on Google Classroom.